Okay, we're gonna move on though to this right here. Example 1. When you go get ice cream with friends, there are many choices. I'm trying to scoot over, I can read it. For you to make. This is goofy. What flavors of ice cream, what kind of topping you want, and what color sprinkles, because everybody needs sprinkles, right? How many different sundaes can you make when you order one flavor of ice cream, one topping, and one color of sprinkles from the chart below? Show all possible outcomes in a tree diagram. So I'm going to show you what I mean by tree diagram. You guys have done this before, I'm certain, but we're going to do it again. And then figure out how many possible outcomes. How many different ice creams we got?
3.
We got chocolate, we got vanilla, we got strawberry. That seems really hard, right? We're done with that. Then we got, what kind of topping? Fudge and marshmallow. That's what that looks like. Then we got vanilla, and we could have fudge and marshmallow. Then we got strawberry, we can have fudge and marshmallow. And then we're done with that. Now what color sprinkles we got? Chocolate and rainbow. For everybody.
I've done this before.
Did you say you feel like you've done this before?
Yeah. Oh, it's just almost a vacation.
So there's our tree diagram. What do you say?
I just do so much vacation.
What does it mean? The vacation? I don't know what you're saying.
Yeah.
Isolation?
Multiplication of the good.
Yes, that is how you do it. How many different outcomes are there? Well, there are 2 different ways to find it. First, you could count these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or you could do what Yandel said, and you can do vacation. I'm just kidding. Multiplication. How many are here?
3.
How many are here?
2.
And here?
2.
What's 3 times 2?
6.
Times 2?
12.
12.
That's all you have to do.
That's it.
That's easy.
Well, I told you guys at the beginning of the year that math is easy. The reason most people think math is hard is because you think math is hard. It's not. It's pretty simple. Right? If you just open your mind and realize it's going to be easy. Okay. Example 2. A neighborhood deli sells sandwiches that can be made with the ingredients listed on the board below. Draw a tree diagram to show all the possible bread, meat, and cheese possibilities. If a sandwich has 1 type of bread, 1 type of meat, and 1 type of cheese. So obviously we can go ahead and figure out how many possible outcomes are there. How many are there?
3.
No. Try again.
8.
How many?
8.
18.
How many?
18.
18. How'd you get that? 3 times 3? 9 times 2?
18.
18. But we're going to write them down anyway. That's rye bread. That's rye bread. What's that other one called?
Rye.
What is it?
Rye.
What is it?
Pumpernickel.
Pumpernickel. You ever had pumpernickel bread?
Nope.
Don't do it. It's nasty. But it's still fun to say, isn't it? Pumpernickel. And then we got ham, turkey, and what? Bologna. That's why the English language is hard, because bologna spells bologna. Stupid. Ham, turkey, bologna. My bologna has a first name, it's O-S-C-A-R. My bologna has a second. I'm recording and singing a song. Oh, I love to eat it every day. If you ask me what I'll say. Okay, now what do we do here?
Now you make another one.
For
American
cheese.
and provolone.
Provolone. Love me some provolone cheese.
I like sliced cheese.
Did you say sliced cheese? I like all cheese.
What's provolone?
It's kind of a white cheese. It's not real strong.
Is that pepper jack cheese?
I like pretty much all cheese except Swiss.
I like it.
Swiss cheese? It's not green.
I mean, like cheese is like I think was invented because I love it.
I like whipped cream.
I don't really like I said though, I don't like Swiss cheese. Swiss cheese is nasty. It smells like
It is. It tastes like chemicals. What does?
it tastes like it smells like feet. I don't know what it tastes like. All right, go ahead. There's your sample space. Make sure you get it all written. I believe you put that computer down. Okay, and so we already determined there were 18 outcomes, right?
Yeah.
But if you count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Good. Has everybody got it written?
Yes, ma'am.
Everybody good to go?
Yes, ma'am.
Good.
18.
Turn the page. Practice. You're at a carnival. One of the carnival games asks you to pick a door and then pick a curtain behind the door. There are 3 doors and 4 curtains.
I'm not supposed to eat it.
Draw a tree diagram. How many possible choices are there for the player? How many choices are there? 12. How'd you do that?
Because it looks like 4 times 3.
Good. I'm not going to make you draw the tree diagram.
Just write 12.
There are 3 trails, moose, eagle, and raccoon, leading to Camp A from your starting position. There are 3 trails, crow, snake, and lizard. From Camp A to Camp B, how many different routes are there for the starting position to Camp B? 9. Good. I think you guys got this. If you do not, there's some extra practice there for you. We're going to turn all the way to page 5. Using experimental data for simple and compound events and probability. We have already visited this year. Why are you saying uh-oh, Caden?
Because it looks complicated.
Okay, first of all, stop saying uh-oh and stop thinking things are hard. They're not. You know how to do this. Okay? What is a simple event?
1.
1. Pretty simple there, right?
Oh no.
1 event. What is a compound event?
More than 2.
More than 1, right? 2 or 862. I don't care. More than 1. What is an example of a simple event?
1.
1 car.
Like,
Oh.
out of 368 cards, there's only 1.
Less than 1?
What?
Less than 1?
No. What is an example of a simple event? Something that's happening.
It's a 1 card.
1 carnival game. Good. How about ice cream?
Oh, yeah.
If you were me and you don't like anything fancy food wise,
You know?
when I eat ice cream, I eat ice cream. I don't want anything on it.
One vanilla ice
You.
cream. You don't like
Okay, I don't want no chocolate, nothing. Maybe some caramel, but usually it's just vanilla ice cream. That's all I want.
I eat chocolate.
Okay. A compound event would be ice cream and topping. Okay, you with me? All right. Easing on down. Probability is a measure of how likely an event is. What is probably going to happen? If you look at example 1, let's not make this hard, okay? A spinner has 4 equal sectors colored yellow, blue, green, and red. What are the chances of landing on blue after spinning the spinner? Well, how many different colors are there? 4. How many of them are blue?
1.
That's the answer.
Hmm?
Is that lowest form?
Yes.
Yeah. What are the chances of landing on red?
1.
That's it. If you look at experiment number 2, a single 6-sided die is rolled. What is the probability of rolling an even number? How many are there?
5.
6. How many of them are even?
5.
3. And that simplifies to 1/2. So if half of them are even, how many are odd?
1/2.
Half. Good. What is the probability of rolling a 5? Well, how many sides are there? 6. And how many of them are a 5?
1.
1. That's it.
Easy money.
Pretty simple. Experiment 3.
Experiment 3.
A glass jar contains 6 red, 5 green, 8 blue, and 3 yellow marbles. If a single marble is chosen at random from the jar, what is the probability of choosing a red marble, a green marble, a blue marble, a yellow marble? What is the probability of choosing a red marble? How many total are there?
18. Is that right? 11.
22. 22.
How many of them are red?
6.
Is that lowest form?
No.
What is?
Divide by 2. 11.
3 over 11.
Good. How many marbles are in the jar still? 22. And how many of them are green?
8. That would be 32.
5.
Is that lowest form?
Yes.
How many marbles are in the jar?
22.
And how many of them are blue?
8.
Is that lowest form?
No.
What is?
4, 11.
2 over
And the last one? 22. And how many are yellow?
3.
Lowest form?
Yes.
That's it. Which of the following is an experiment? Tossing a coin, rolling a single 6-sided die, choosing a marble from a jar, or all of the above?
All of them.
All of the above. Good. Let's look at the we do section. What is the probability of choosing a vowel from the alphabet? Y is not a vowel.
5.
Out of?
25.
25.
26. Is that lowest form? Dalen, for the love, I do not want to look over there and see your head down on that desk again. That's like the 4th time, dude. Number 2, a number from 1 to 11 is chosen at random. What is the probability of choosing an odd number? So how many are there from 1 to 11?
10.
6.
How many numbers are there? 1 to 11.
12.
And how many of them are odd? 1.
6 or 7. 7. 11.
1, 3, 5, 7, 9. How many? 6. Is that lowest form?
Yes.
Good. Number 3. What is the probability of choosing a king from a standard deck of playing cards?
Never.
How many cards are in a deck? Anybody know?
54.
Close.
25.
Yeah, I'm telling you.
How many of them are kings?
2.
2. There's a 2 copy of each.
No, there's
Actually,
way
there's
more
4
than
copies
that.
of each.
4.
Yeah.
That's not way
4 is not way more than 2.
Oh. Well, this one
Is that lowest form?
No.
What is?
Divide by 2.
13.
Is that lowest form?
No, you can divide by 2 again.
Which is
12.
1 over 13. Good. Number 4. What is the probability of choosing a green marble from a jar containing 5 red, 6 green, and 4 blue marbles? How many total are there?
Oh.
15.
How many of them are green?
6.
Is that lowest form?
Yes. No, you can divide by 3.
What?
3 over 2.
3 over 5.
2 over 5.
5.
There you go. This next one is what's called the complement of an event. It's when they put this word right here in there. Not. What is the probability of choosing a marble that is not blue in problem 4? Well, there are 15 of them, right? And if 4 of them are blue, how many are not?
11.
Is that lowest form?
Yes.
Yes. Just got to read that little word, not. Okay, turn the page. So now we're going to talk about compound probability. Compound probability is when how many things happen?
More than one.
More than one. And they're in the pinkish purple area part there. We're going to talk about that for a minute. Okay, we're going to talk about dependent and independent events. What does it mean if an event is dependent? Please don't read it to me. What do you think it means?
It's by itself.
What do you think, Maddie?
They can do it on their own.
Yeah, on your own. Yes, that does mean dependent.
Wait.
Well, dependent's not on your own. Dependent is independence on your own. What do you think a dependent event is?
Relying on a single event.
Relying on something? Yes. For example, if my actions affect you, are you dependent on me?
Yeah.
Yes. If my actions do not affect you, then you are independent of me. Are you with me?
Yes.
Like you staying in your house all last week was a dependent event because the weather made you do it, right? So it's something changes or if something doesn't change. That's pretty much it. So let's look at situation one. And I want you to just watch instead of writing. I want you to just listen and look at situation one because that is a dependent event, which means event number one affects event number two. Please make sure your heads are up off your desk and you're paying attention. The names of 16 students are put into a hat, 9 boys and 7 girls. What is the probability of picking a girl's name first, not replacing it, and a boy's name second? That is a dependent event. How many names are in the hat? How many of them are girls? 7. Is that lowest form? Yes, please don't write. Please just watch. This is event number 1. Event number 2, they did not put the name back in the hat. Now how many names are in the hat? 15. And how many are boys? 9. The way you do compound probability is you multiply, but before I multiply, I like to make sure all my fractions are in lowest form. So is this lowest form?
You
You divide it by 3 and it gives you 3/5. This is event number 2. Okay, so we're done with 9/15 and now it's 3/5. So now to do compound probability, you multiply. How do you multiply with fractions? Straight across. And that is that lowest form? Yes, it is. Do you see what I did there? The second event depended on the first event. That means you did not put the name back in the hat. You with me? All right, go ahead and write that down. If they would have put the name in the hat, this number would not be 15. What would it be? 16. Good. Look at situation 2. 2 cards are chosen at random from a deck of 52 cards without replacement. That means you keep it out. What is the probability the first card will be a jack and the second card is a 10? So there are how many cards in a deck? How many are jacks? 4. Is that lowest form?
No.
No, we did it earlier. It's 1 out of 13. This is event number 1. Now we are not replacing it. How many cards are in the deck? No. No. 51. How many are 10s? 4. Is that lowest form? Yes. How do you do compound? Multiply. I'll do the top. They'll do the bottom. What'd you get? How many?
663.
663? Perfect. All right, situation 3. A basket contains five apples and 7 peaches. You randomly select one piece of fruit. Do not replace it. Then you randomly select another piece of fruit. What is the probability the first piece? We're going to change that. We're going to make that replace it. Mark out do not. You replace it. Hold on. We're going to do this one before we clean.
You can,
Okay. So the first piece of fruit is an apple and the second piece is a peach. How many are in there?
5.
no.
12. And how many are apples? 5. This is number 1. Is that lowest form?
Oh, yes.
In event number 2, you did put the apple back in there. So how many are in there?
12.
12. And how many are peaches? 7. How do you do compound probability?
You multiply it.
You multiply them.
35.
144.
That is the probability. Okay? Make sure your name is on this paper and turn it into the zebra over here. We'll start tomorrow with where we are.
Read the whole thing.